These are the lesson 8.6 notes on natural logarithms. Today we're going to solve some exponential equations with natural logs. We're going to solve some natural log equations. We're going to write some natural log expressions. So first of all, the question bears asking, what are natural logs? Well, we have talked about common logs in class. Common logs are logs that have a base of 10. They're typically written as just log. On your calculator, there's a button that says log. There's also something called a natural log. A natural log is a log that has a base of e. This is also abbreviated ln. These are the initials for natural log, just kind of written in reverse order. There is a natural log button on your calculator. It's found right here, ln. Now a quick review. The letter E in mathematics can be found using second natural log, and you can either have e to the first power typed in your calculator, or if you do second divide sign, this will also generate e. E is an irrational number. It's for 2.718. It's never ending, it's never repeating, and it's often used to model continuous growth. Now, when you're working with logs and natural logs, you do get different values. For example, on your calculator, if you type in log of 6 and natural log of 6, you'll get two different values, 0.78 and 1.79. Likewise, log of 10 and natural log of 10 are two different values. You probably remember that the log of 10 is equal to 1. The natural log of 10, however, is equal to a never-ending, never-repeating decimal, approximately 2.30. Similarly, you can crunch out the log of e and the natural log of e. The log of e is equal to about 0.43, whereas the natural log of e is equal to 1. Now you can use natural logs to solve equations. I first want to start with common logs, the logs that we've typically used up to this point, to solve some equations similar to equations we've solved recently in class. When you're working with 6 to the x power equals 10, you can solve this equation by taking the log of both sides. That is, taking the log of 6 to the x power and taking the log of 10. Now you probably recall to solve this, you can move the exponent out front to the coefficient. So this would be x times the log of 6 equals the log of 10. To solve this equation, you can divide both sides by the log of 6. What you might recall is that the log of 10 is equal to 1. So you could just type in x equals 1 divided by the log of 6, or log of 10 divided by the log of 6. Either way, you get the same answer of approximately x equals 1.28. To solve the second problem, it's the same idea. You can take the log of both sides of this equation. When you do that, you get the log of 10 to the x plus 1 power equals log of 55. Now you may recall again, you can move this exponent out front into the coefficient. I am going to put it in parentheses because it's this entire group. X plus 1 times log 10 equals log 55. Because we're trying to solve for x, you could divide both sides of the equation by log of 10. That's fine, but the nice thing about dividing by log of 10 is that log of 10 is equal to 1. So really, log of 55 divided by log of 10 is log of 55 divided by 1. Anytime you see log of 10, you can essentially just cancel it out because it's 1. So really all we have here is x plus 1 equals the log of 55. And to solve this problem, you can subtract 1 from each side. Don't take the log of 55 minus 1. Don't take the log of 54. Take the log of 55 minus 1. When you do this on your calculator, close off the parentheses after the 55, and when you subtract 1, you should get approximately 0.74. If you're not sure if you're doing the problem right, what you can do is go back to the original problem, type in 10 exponent, this number 0.74 plus 1 in parentheses, and then when you hit enter, hopefully you get something close to 55. Now in this last problem, what we'll do to solve this is to find this exponent. I'm actually going to start by dividing each side by 4. Now you might be wondering, why don't we just take the log of both sides? We could, but the problem is if I took the log of the left side, I'd have to do the log of 4 plus the log of e to the 3x power. It's a multiplication problem which would need to turn into addition. And I just think it's easier. If you can divide out a 4 on both sides, just do that first. It's a lot easier to do that. 4's cancel, and you're left with e to the 3x power equals 6. We're going to take the log of both sides now. This would be log of e to the 3x power equals log of 6. Now you can move this entire exponent, which is 3x. If you want to put it in parentheses, that's fine. Times log of e equals log of 6. To get x by itself, we'll first divide both sides by the log of e. This will cancel out on the left side. On the right side, we also divide by log of e. This will give us 3x equals the log of 6 divided by the log of e. When you type in log of 6 divided by log of e on your calculator, what you'll end up with is a decimal. It's approximately 1.79. I'm not going to round this number yet. I never like rounding until I'm absolutely done with the problem. So I'm going to write out all these decimal places, then I can divide both sides by 3. On your calculator, if you just hit divide by 3, it will take your previous answer and divide it by 3, and you get your solution for x. I'm going to write it up here. X is approximately 0.597. Solving equations with natural logs is very similar to solving equations with common logs. Let's take the same 3 problems and solve them using natural logs. To do 6 to the x equals 10, what you can do is you can actually take the natural log of both sides. So you can write ln before the 6 to the x power and also ln, or natural log, before the 10. The same rules for logarithms apply. You are still allowed to move the exponent out front. So you have x times natural log of 6 equals natural log of 10. We can still divide both sides by the natural log of 6. Here the natural log of 10 is not quite as nice. It's 2.30, and this is a rounded value, so I would just leave it as this. Natural logs of 6's cancel out, and to solve for x, you're going to take the natural log of 6 divided by the natural log of 10. Now when you do this, what might be a little bit of a surprise is the answer you get is exactly the same as what we got when we did it using common logs. It's still approximately 1.28. I just noticed it was 1.285, so let me change that number here, and that's what we got here as well. For the second problem, if we take the log of both sides, in this case the natural log of both sides, we'll have natural log 10 to the x plus 1 power equals natural log 55. Just like before, we're going to move the exponent out front, so it's going to be parentheses x plus 1 times natural log of 10 equals natural log of 55. We'll divide both sides by the natural log of 10. Obviously on the left side it will cancel. On the right side, you may recall last time we had the log of 10, which also canceled. Here nothing else will cancel. So we'll have x plus 1 equals, you'll have to actually do natural log of 55 divided by natural log of 10. Not that that's a big deal. When you do that, the answer we get is about 1.74. I'm not going to round this number yet because we're not finished with our problem. In our last step, what we're going to do is we're going to subtract 1 from each side. I'm okay with you rounding at the end here, and if you take this answer minus 1, we get the same 0.74 value we did last time. Now in our final problem, just like we did last time, we are going to solve this using natural logs, but again, first of all, we'll divide both sides by 4. So again, we have e to the 3x power equals 6. I'm going to write the natural log of both sides. Natural log of e to the 3x power equals natural log of 6. And again, we'll move the exponent out front. So this will become 3x times natural log of e equals natural log of 6. Now, if you remember that the natural log of e is 1, you can basically cancel this out right here. And all we have is 3x equals the natural log of 6. Now all we have to do is divide both sides by 3. And when you take the natural log of 6 and divide it by 3, the solution of 0.597 reappears again. Now, what's the moral of the story? The moral of the story is this. There are some instances where it's to your advantage to use common logs. I would say in the second problem, if you get this step where you're dividing by the log of 10, that's kind of a nice thing. That's like dividing by 1 and it cancels. So problems where you have a 10 as the base before your exponent in exponential form, these are problems where you probably want to use common logs. However, on a problem that involves this e as your base, like we have right here, using a natural log is to your advantage because when you do a natural log of e, this cancels out. So when using natural logs, be aware of there being an e in the problem, and that's probably to your advantage. On problems that don't have e's or bases of 10, you can use either one, and it really doesn't make a difference as far as how long it takes for you to solve the problem. So use common logs when you're working with base 10 problems. And you want to use natural logs in problems where the base of your exponent is e. So finally, the last thing we're going to do today is we're going to solve some equations that have natural logs in them, and we're going to rewrite some natural log expressions. Here's an equation: 4 times natural log of 3x equals 10. Our goal is to figure out what x is equal to. I think dividing by 4 obviously makes sense here because you can cancel out the 4's, and we get natural log of 3x equals 10 divided by 4, which is 2.5. The base for a natural log is e. So to solve a natural log equation, we're going to write it in exponential form. Just like to solve a traditional log problem, we're going to write it in exponential form as well. The base of natural log is e, so we're going to take e to the 2.5 power equals 3x. Now you can crunch this out, or if you want to, just immediately divide both sides by 3. This will allow you to solve for x. And to find x on your calculator, we can go second natural log, this is the e value, and it takes it to a power, so we'll go e to the 2.5 power divided by 3, and that's equal to about 4.06. Here's a way of solving the second problem. Again, we're working with a natural log, which is a base e log. We're going to write this in exponential form, obviously, so this is going to be e, here's your 4th power, equals parentheses 2x plus 5 to the 2nd power. Our goal is to solve for x, so obviously one thing we're going to want to do is square root both sides. You may recall when you solve x squared equations, when you square root both sides, there's going to be 2 solutions. So when we square root both sides, there's going to be both a plus and minus answer. On the right side of the equation, the squared side and the square root cancel, and you're left with 2x plus 5. On the left side, it's the square root of e to the 4th, which is e to the 4/2 power, or e squared. It is going to be plus or minus this value. If you want to calculate it as a decimal, that's fine. You would just do the square root and then e to the 4th power, and that is equal to e squared. If you weren't sure, you could even crunch it out, and you'll notice you get the same values. I'm going to leave it as e squared for right now. Once you have it this far, the rest of the steps are pretty easy. We're going to subtract 5 from both sides. So it's going to be plus or minus e squared minus 5. On the right side, we have 2x, and then we'll divide both sides by 2. So when you crunch this out, there's actually going to be 2 answers. One of them is going to be negative e squared minus 5. This whole thing divided by 2. So we get a negative answer of negative 6.19. Or you could do positive e squared minus 5 and divide that answer by 2. And you get 1.19. Both solutions actually check out, and they're both valid. The last problem is a natural log problem where we're going to write this as a single logarithm. To do this, you may recall that we move our coefficients into the exponents. So what you'll get is natural log of x squared minus natural log of y cubed plus natural log of z to the 1/2 power. And then if you remember that subtraction turns into division and addition turns into multiplication, this problem is treated almost the same way that we treat common logs, where we write natural log of x squared, the minus becomes a division of y cubed, and the addition becomes a multiplication of z to the 1/2 power. Even better, if you recall that z to the 1/2 power is the same thing as the square root of z, you can get a solution that's a little bit more compact. Natural log x squared times the square root of z over y cubed. And what we've done today is we have talked about solving exponential equations with natural logs and with common logs, when you should use each type, and how to solve natural log equations and rewrite natural log expressions.